The duckweed experiment has officially concluded, so let's get back to experimentation from home, but through a video, and I'm doing it. This is going to be really cool because what we're going to be doing is analyzing the results and discussing how they can be used in practical ways. Because I'm sure you are wondering, what's the point in trying to grow duckweed in acids and bases? Why is this knowledge useful? But first I need to prepare myself for looking at my screen at this really cool data. I said the data is cool, not that I want to look cool. I can't actually see with these, so let's try again. Oh wow, my hair is kind of crazy today, I didn't realize that. It's out of my face though. Let's get looking at this data and seeing what it tells us. I'll share the actual results and we'll process them together in a moment, but first I wanted to show you the actual results. Duckweed grown in neutral pH was the only one that actually increased in numbers of plants and leaves. The root systems also got extremely well developed. What I found was interesting is that closer to the light source was the greatest amount of growth, and further away there was less. Duckweed grown in bleach or vinegar all died, and over the course of the experiment started developing mold while they decomposed. There was an initial increase in the number of plants, but really no change in the number of leaves. As you can see here, there is all of the duckweed data from the first experiment, where I tested 3 different concentrations of vinegar solution along with a neutral solution. We're going to do some data processing and look at it closer, but first I want to share with you also the results from the second experiment, where I modified the procedure a little bit to test a narrower range of vinegar concentrations and also test out different bleach concentrations so that I have different ends of the pH spectrum represented. And again, we'll do some data processing with it and then some graphing of those results. First, I want to start off with doing some calculations for the, oops, sorry, I wasn't supposed to touch my head. It's coronavirus time. To do the average number of leaves and plants in the different trials of the experiment. What I want to do first is calculate an average number of plants and leaves within the concentrations for the different days, and we'll do some playing around with that in a short bit. First, I'm going to type in my formula to calculate the average, and I'm going to select all of the 4 values that are from the same day and the same variable. When I click enter, I get an average of 5. That makes sense because there were a total number of 5 plants in each of the 4 trials. If I click on that and drag it down, it will calculate the average for all of the days for that particular variable. I'm going to quick repeat that with all of the leaves. And I'm all done with calculating my average number of plants and average number of leaves for one concentration. I'll be right back after I calculate the rest. Now that I've calculated the average number of plants and leaves on each day for each concentration, as you can see in columns K and L, I can do a couple of different things with them. I'm going to create a couple of different graphs. The first is going to be one that shows a line graph of the change in number of plants and change in number of leaves over time. The second type of graph that I'm going to create is one that shows the total difference from the first to the final day of the experiment, and I will construct a bar graph or a column graph to represent that. In order to create my line graph, I'm going to highlight the entire table. From there, I'm sure it will populate the labels and the different scales for the axes based on what I highlight here. If I select Insert, Chart, and it's going to provide me with one that it initially thinks that I really want to have. which it's showing a line graph. There's a couple of things I want to do in order to make this graph a little bit more useful as far as what it's telling us. The first is going to be a title. I also need to add axes labels. I can see those changes a lot more. Now, what I find interesting about this graph and what it's telling me is that there was a much more drastic increase in the number of plants in the 1 and 5% vinegar solutions. They plateaued along with the 20% vinegar, and then they dropped off suddenly. What is going on here? Now, this is the reason why, as I was collecting data, I was happy to record the number of leaves, because what we should see here is if there's a change in the number of leaves along with the number of plants, that should represent growth. And I'm going to insert a chart the same way. And whereas the number of leaves slightly increased in the 5 and 20% vinegar solutions, they remained relatively constant until the 6th day. And it wasn't until I collected data several days later where I just cleaned them up because they were clearly dead, they were rotting, and so they didn't necessarily need to continue going on. That is what makes this data really, really cool. I can tell that even though there was a number of increase in plants, the amount of leaves for the vinegar solutions remained constant, and then they died. Let's do one more type of graph so that we can see more clearly what the real difference in the growth was. For that, I'm going to do a simple equation where I take my final and subtract my initial. I'm going to click and drag that over. I'm going to do the same for the number of leaves. I'm going to insert two graphs. This time I'm going to have it showing columns. I'm going to highlight those cells, insert a chart, and hopefully it'll suggest a column. Yep. I'm going to do the same with this data. And so what I can see with these two column graphs side by side is that the neutral solutions were the only ones where there was an increase in the total number of plants and an increase in the total number of leaves. Again, while there was an initial increase in the number of plants for the acid conditions, that was likely due to them splitting up due to the stress of the disturbance in their conditions, which was an acidic environment. I'm going to replicate the same procedure, same data process, but using a lot more data. This time I'm going to be using all of my second experiment data, create the same two types of graphs, and then share with you my interpretation of the results. All right, so here we have a pair of graphs. There's two things that I find interesting about them. The first is, well, I guess just one thing that I find interesting about them, that they have the same exact overall pattern that was seen in the original duckweed experiment that tested the much more strong acid conditions, where there was an increase in the number of leaves, but a steep drop-off in those conditions that weren't a neutral pH. And the neutral pH is the only one that saw an increase steadily throughout the experiment. That goes with the number of duckweed leaves too. That in the neutral condition only was where there was an increase in the number of leaves, whereas in all of the other conditions with acid and base, all decreased over time, resulting in their death, which is how they all ended up at 0. If we look at the other two graphs, the column graphs that just show the total change in the number of duckweed plants and leaves per condition, comparing the final and the starting day, what we can see is that in the only condition where duckweed plants grew Increasing the number of leaves and plants was in the neutral condition. All else saw a decrease. So the data tells us some stuff, but what is really meaningful about it? Why was this experiment worthwhile doing? Well, to be honest, at school, I wanted to build more lab experiences and allow you to do some more experimentation in class, especially since we've been talking a lot about disturbances and how those can affect biodiversity and community structure. However, in these quarantines, I have had to make adjustments in my own living arrangements with my fish, and I'm going to share some more information about that with you in a short while. But what I can now know is that having to clean one of my aquariums out completely of duckweed and algae, I can use both acid and base in lower concentrations than I imagined and sterilize it for a completely different purpose, where I can use some of my innovative skills and ideas to solve interesting problems to me. Now that I know that both vinegar and bleach are effective in killing duckweed, I need to choose which one of those two I want to use in this upcoming project that I'll share with you very shortly what it is. As you can see from this very easy, simple, quick, whatever Google search, I can use either vinegar or bleach. Vinegar is good to use as a quick, efficient solution. If the tank had sick fish, I should use bleach, but there weren't any sick fish in there. And so I'm going to get to creating a vinegar mixture so that I can start this next project. See you later!